here, here, they are sp2 hybrids. The yellow balloon represents the p orbital that we did not hybridize. And now if you would step in, what we're going to do is we're going to bring these two molecules together. So now we again have in the center the sp2 and the sp2 from the two carbons. They form a sigma bond between the two atoms. The unhybridized p orbital, hand up here please. Thank you. And down here please. Thank you. The p orbitals above and below the atoms overlap and they form what is now called a pi bond. Pi bonds are difficult for students to visualize, and I don't even attempt to draw them on the board because they're much more complicated than my meager skills can do. But we get this picture now of what a double bond looks like. We've got the overlap of the p orbitals represented by the yellow balloons above and below, and the sigma bond that would be represented to the center. Thank you. We'll toss those to the side. And we'll form the sp hybrid at this point. The sp hybrid, excuse me, has two orbitals which are hybridized, but remember from our diagram previously that it also has p orbitals that are unhybridized, not one, there's one of the p orbitals, but two. So what we have represented here is an sp and an sp hybrid. The blue represents an unhybridized orbital here, and the yellow represents an unhybridized p orbital here. So we've got one of those. Thank you. We'll construct one more. Oh, anticipating. And for this, we're going to need a third volunteer. So if I could have a third volunteer up, please. So again, the same process that we had. We've got the unhybridized orbitals that are the p orbitals. I'll let you have that one. Let's see, we've got to orient it like this. And you're going to come around the back. Great. So in the center, as we've had before, this is an sp and an sp, and those overlap along the plane of the nuclei between the atoms. That forms a sigma bond. It's a sigma sp if you want to call it that. As we had before, hand on top, and down below, hand on bottom. You're great. That forms the p bond that we had before, the pi bond, and so there's the double bond arrangement that we had. Then, hand in front, great, and back behind. Yeah, this gets complicated. Now we have that third pi bond, which is located inside of that. So we have the sigma bond in the center, which is the stabilizing bond. We have one pi bond here, and we have the other pi bond around the center here. And that gives this nice visual picture for the students. If you want to get complicated with this, then you could actually have yet another set, and you could show a double bond. Two double bonds next to each other, which also require sp hybridization to make that happen, depending upon what level that you want to move with your students. Thank you for the help there. You may be seated.